Control structures. First, let's talk about decision structures. Decision structures let you test the conditions and perform different operations depending on the result of the test. The condition is tested. If the condition is true, then perform actions for when the condition is true and run the next code. If the condition is false, then perform actions for when condition is false and run the next code. The first decision structure is if-then. There are several variations. The first variations let you test for the condition. If the condition is true, then do something. Otherwise, don't do anything. The second variation checks for the condition. If the condition is true, then do something. Otherwise, do something else. The last variation checks for multiple conditions. As you can see here, there are multiple if and else if, and at the end there's an else branch. So anything that didn't go into any if or else if branches will be here. Okay, now if you write code for Visual Basic in Visual Studio, you create a blank project and then add a module. If you write VBA code in Excel, then create a new workbook and open Visual Basic Editor and then add a module. Okay, now in Visual Studio I have the Professional Edition. Click New Project and then select Windows, and from here you select Empty Project. You specify the name of the project, and let's say example lecture 1. Then click OK. You add a new item, or you can directly select a module. So I have pasted the code from the lecture. At the top of the module, you can see there are several variables. There is a variable for interest type. It can be simple or compound interest. Interest rate, accumulated value, present value, and also the number of years. Var answer is to store the answer from the user. The sub-procedure, namely main, runs by default, and it calls accumulated value which is down here. In this sub-procedure, there are several blocks. Each one accepts the input from the users. For example, input box displays a prompt saying enter interest rate. So when the user types in the interest rate, it is stored in var answer. We'll talk more about this later when we go to the loop structures. So there are several other blocks for present value and the number of years, and then it displays an input box, and the user selects either S for simple interest or C for compound interest. If the interest type is simple, then the accumulated value is calculated following this formula. Otherwise, if the type is compound interest, then the accumulated value is calculated following another formula. And if the user types in anything other than S or C, then it shows a message saying wrong selection. And at the end, it shows a message box saying the accumulated value is. So here you use the format function to format the numbers the way that you want to. So it forces 3 digits here, and also the dollar sign in front of the value. Now let's run this. You click the start button. Okay, now it asks for the interest rate. Let's say you type in 1%, and then the present value, let's say it is 100, and the number of years, let's say 10 years, and then you select C for compound interest. Now it shows you the calculated value for accumulated value. Now let's see how we do this in VBA. So you open the Visual Basic editor and then add a module. So you can right click and select insert, and then module to insert a module, and then copy the code from the lecture. And of course in VBA you don't need the module and end module. And you use the functions L case for lowercase and U case for uppercase. So the code is very much similar. Let's see how it works. You click the run button, and also you type in 1% for interest rate, 100 for present value, 10 for the number of years, and C for compound interest. And that's it. And this is the reminder for the formulas for simple interest and compound interest that you can get from the financial mathematics 1. Another decision structure is select and select. So here you test the variable to see if it is equal to a value, then you do something here. Otherwise, you check other cases. You can also compare the variable with more than one value. For example, value 2 and value 3. You can also test if the variable is between value 4 to value 5 or less than value 6. And otherwise, then it goes to case else and do something else. Now let's go back to the same example. Instead of using if and if structure, you use select case. Select case, and you compare the variable str interest type. If it is equal to lowercase s or uppercase s, then the accumulated value is calculated using the simple interest formula. Otherwise, if it is equal to uppercase or lowercase c, then the accumulated value is calculated using the formula for the compound interest. And if the user types in anything else, then a message is displayed saying wrong selection. Over here you can also use either U case or L case, and then in each case you just have either S lowercase or S uppercase, and that's another way. Loop structures are the second type. So loop structure lets you run one or more lines of code repetitively. So you perform actions to be repeated, and afterwards you check the condition. If the condition is false, then you perform the actions again. Otherwise, you exit the loops and run the next code. The condition checking can be after performing actions or before performing actions. First, let's talk about do loop structure. In the first variation, the condition is tested before performing the statements. The statements run as long as the condition is true. In the second variation, the condition is tested after running the statements. Now let's go back to the same example. Let's look at the do loop structure. Do while not is numeric var answer. So this means that if the user types in anything which is not numeric, then the input box functions keeps displaying the message enter interest rate, and it displays again and again until the user types in a numeric value. Similarly, there are two variations. In the first variation, the condition is tested before performing any statements. In the second variation, the condition is tested after performing the statements. So with the second variation, the statements run at least once. With the same example, here you can see how we change from do while to do loop until. Another loop structure is for next. You use this structure when you know how many times you have to loop. So for an index variable from a start value to the end value with a specific step, you run the statements. Let's look at the example for next structure. The function identity matrix has one argument, int size, as integer. There are two local variables, I and j, as integer as well. And then you declare a matrix, actually an array, namely int matrix, with a size from 0 to int size -1, and from 0 to int size -1. Now you have two loops nested. You loop through elements of the matrix and assign 1 to the elements on the diagonal. And finally, you return the matrix int matrix. Later on, you declare a variable int max, and you call the function identity matrix and give it 3 as the argument. This function returns an identity matrix of 4 by 4 to int max. Another loop structure with 4 is for each next. This structure is very useful when you work with collections. So for each element in the collection, you run the statements. Now let's look at this example. You create a function, namely matrix sum, and it takes DBL matrix as the argument, and this is a double type Then you declare two variables, dbl lm as double and dbl sum as double. Now in the loop, for each element dbl lm in the matrix dbl matrix, you sum the value in dbl lm to the sum and save the value to the sum itself. You do this again and again for all the elements, and finally you return the sum, dbl sum. There are other control structures like with and with, using and using, and try and try. Those two structures are used in VisualBasic.NET. Okay, so this is the syntax for with and with structure. With object, you run the statements. So you don't want to repeat the object multiple times in the statements. You write with and then the object name, and in within the with and with structure, you just need to start with a dot and then the member names here. This is example for with and with structure. If you don't use with and with, your code looks like this. You have to prefix the member with the object name every time. But with the with and with structure, you can write with and then the object, and later on you just need to start with a dot and then the member, for example make, and assign corresponding strings or values to them. Try and try structure provide a way to handle errors. So the statement you want to run, you put in try, and when the error happens, you want to write some code in catch to catch and probably show the error. This is an example for try and try structure. So you try to send a request to Microsoft.com. If something happens, let's say some error happened, then in the catch block, you display a message saying cannot load web page, and then also the message in the error.